Up to the last class, we already have discussed some aspects of atoms and molecules. Generally, last class our topic was in how many different form an atom can exist, like in monoatomic form, or in diatomic, or in triatomic, or tetraatomic, or polyatomic, or just like that. So there are varieties of bonds with which an element can exist, and that depends generally upon its kinetic energy. If its kinetic energy is more than the escape velocity, it will just go away from Earth's atmosphere. But to prevent that escape, an atom can willingly connect with another one atom of its own kind to form a molecule. What kind of molecule there will be? That depends upon the energy level of that atom. So just in the same way as chlorine was forming chlorine in diatomic form, like Cl2, or phosphorus, which was forming a molecule of 4 phosphorus atoms. So there are varieties of shapes or varieties of bonds in which they can connect. Yeah, the bond is just there is one common, that electrostatic bond, which comes out from the mutual sharing of electron. But one fact is here is that if any atom removes one of its electron or more than one electron from its outermost orbit, or accepts another one or two or three electron from other atoms, or that free electrons, then that atom is not called atom but is called ions. Positive ion, if that atom removes one of its electron, then because of the proton which exists in the nucleus, and that one proton of which the cancelling element, the electron, is now just got removed from the atom, dominates on the entire atom and make the entire atom behaves as a positive ion. So just in the similar manner, if an atom accept one or two electron, there is no extra proton which is present in the nucleus to cancel out the negative charge of electron. So because of that, electron charge gets dominated over the atom, and finally atom behaves as a negative atom, that is called ion. The factor here is, generally we've come across a point where now we have to deal with the mutual interaction between two or more than two atoms together. What happens when one atom X connect with another atom Y? It will surely form something which will be called XY, just as an example. Okay? Generally we see the example like if carbon is connecting with oxygen, it is forming as carbon dioxide. If you have 6 carbon dioxide plus 6 water, you can get 1 molecule of glucose as a product. Okay, this is the case, basic cases, that if you have some raw materials as a reactant, that raw materials could be atom, or a set of atom, or a group of molecules. So here is the thing, like you cook food by mixing different elements, by different spices, different materials, just in the same way you connect different atoms or molecules in certain proportion to get something, and that we call product. But how two elements connect? What is the criteria behind the interaction? Basically there is two. In chemistry, if we talk about the bonds, generally there is a concept of bonds in which we generally talk. First of all, let me remind you something. To make any chemical reaction viable, if you want to do any chemical reaction, for any chemical reaction you need two different things. First, valency. Valency. What is the valency of element? Whether it is electron giving or electron receiving. If something has electron, which according to octet law comes out that it has less than, just say 1 or 2 or 3 electron, as in electronic configuration we already have discussed that if any element has the valence valency of 2 electron or 3 electron or 1 electron to fulfill the octet, then this will be termed as negative. Like, how many electrons are needed to clear or to fulfill the octet law? In previous classes, we have discussed that if any element has just 1 electron or 2 electron or 3 electron in its outermost orbits, it will surely donate its electron. Why? Because it's difficult to get 7 electron or 6 electron or 5 electron to complete its octet. So it's easy to give 1 or 2 or 3 electron to become chemically neutral. But it doesn't happen. In the case of electron donation or electron receiving process, atom becomes ion, and ion is generally reactive. So first thing is clear. First thing is about how much number or which number is represented by an element. What is the valency of the element? Whether it is +2, +1, +3, or -1, -2, or -3, or +1, ±4. So first thing we keep in our mind that the valency, and according to octet law and with the electronic configuration system, you can get the value of valency. Okay. Second thing that you keep in mind, the reactivity series. Reactivity series means which element is actually more reactive and which element is generally less reactive with respect to another one atom or element of atom. Let's get it straight. Look, if I have element X, atom, maybe it's an atom or a group of atom X plus, I have already one molecule YZ. Okay, so here if X plus YZ, I want to make a molecule, then you need to keep in mind that if X is more reactive than Y, then X can connect with Z. But if X is less reactive than Y, the molecule will be same as YZ. But if, just in the first case, as formerly I was saying, that if Y is less reactive than X, that is X is greater than Y, X is more reactive than Y, then X will connect with Z and Y as a byproduct. So in the basic chemistry, generally we learn that reactivity series is one of the profound base structure that we generally have to remember in our brain, so that we can use that series while doing any chemical reaction. Generally this happens when we include a salt, a single salt or double salt, or generally in single salt method. If we use some single salts, then generally this reactivity series comes out into its full play. Okay, this is what I'm calling reactivity series. Here it is K, potassium, then sodium, barium, calcium, magnesium, aluminium, zinc, chromium, iron, cadmium, cobalt, nickel, tin, lead, hydrogen, copper, mercury, silver, gold and platinum. This reactivity series decreasing from up to down. So here in short you can say that potassium is the most reactive element and platinum is the least reactive element or non-reactive element. As you come down from potassium, as you descend from potassium, you will see that reactivity of elements decreasing. Okay, so potassium is more reactive than sodium, sodium is more reactive than barium, barium is more reactive than calcium. Or in the second manner, you can say that if sodium is more reactive than barium but at the same time less reactive than potassium. Aluminium, more reactive than zinc but less reactive than magnesium. So the thing is, how we use these things. Generally, I told you that valency and reactivity series should be kept in mind while making any chemical reaction. So the first thing here is, let's see what is the valency of potassium, sodium, barium, cadmium, etc. Okay, Potassium has valency +1. Potassium has valency +1. It means potassium has 1 electron in its valence shell. So according to octet law, it will need 7 more electrons to complete its octet. So is that possible? So what's easy? To give out one of its electron or to receive 7 electron? In which process less energy will be consumed or less energy will be needed? So just if it will release one of its single electron of the outermost orbit. So potassium has valency +1. The least number will be the valency. That least number should be like the least number of electron which have to expel to attain the octet configuration, or the least number of electron that have to get from outside to get its octet structure. Potassium has already electrons embedded. As you make its electronic configuration, you will get it right. Sodium has +1. In the barium, it is also +1. Oh, sorry, +2. Calcium +2. Magnesium +2. Aluminium +3. Zinc +2. In the same way, if you go through all these things, you can get the valency of these elements. Okay? These basic elements have their own valency. It means they have their own number of electrons that they will transfer from itself to attain the ionic configuration. They will get the ionic configuration, and finally they can connect with another one element. Basically, we start with one single atoms of 2 different elements. Okay? Here, just give me a second. This reactivity series is a must to remind for everyone. If you don't remind this reactivity series or don't keep in mind which element is more reactive than the other elements, then it will be very difficult for you to make or to prepare chemical reaction. Okay? Let's start. Take an example of sodium and chlorine. Sodium is an element and chlorine is also an element. Sodium has valency +1. Like if you make the electronic configuration of sodium, 1s2, 2s2, 2p6 and 3s1. You can see here that after the comma, 3s has just 1 electron. So it will create valency +1. It will donate its 1 electron. And now the chlorine. Chlorine has electronic configuration 17. 1s2, 2s2, 2p6, 3s2, 3p5. So in the outermost orbits there are 7 electrons. So what's easy to attain the octet configuration? Look, here already octet is present. But here they can also get octet if they receive just 1 electron. And here even for sodium octet is there, but just 1 electron is disturbing the whole scenario. So it will leave its 1 electron and it will just get the 1 electron, because it's easy to receive 1 electron than to give out the 7 electron of its outermost orbit. So in the manner we learned that sodium has 1 electron to give and chlorine has 1 electron to receive. So in that manner, one sodium can easily connect with 1 chlorine, because 1 electron sodium will release and chlorine 1 electron that will be received by itself. Okay, so sodium plus chlorine, they will form sodium chlorine. Oh sorry, sodium chloride. In the easiest manner, if I tell you that if sodium and chlorine are there, so look, we know the sodium is monoatomic. Sodium always exists in a single atom, but chlorine always exists in a diatomic form. How will we get the balanced product? Because according to John Dalton, the left hand side of atoms should always be equal to the right hand side of atoms. So the total number of atoms in the left hand side should not be unequivocal or unequal to the right hand side of atoms. So there must be a transparency, there must be equivalency between left hand side and right hand side. So if there is one sodium and one molecule of chlorine, because chlorine always comes in a molecular form, okay. So we know that one chlorine has the ability to receive one electron, but there is two chlorine. How many electron they receive? Two electron. How many so how many electron a single sodium atom will give out? Just one. So how many sodium we should require? Two. In the case, we can form 2 NaCl. We can form 2 sodium chloride molecule, the common salt molecule. Even the other method is write sodium here, chlorine here. This is the cross method. What is the valency of sodium? +1. Okay, no problem. What is the valency of chlorine? -1. Cross it. How? 1. Sodium is pointing to 1. How many sodium is there needed to form sodium chloride? Just 1 sodium. And how many chlorine is needed? 1 chlorine atom. So there is sodium chloride. Just take another example. If I want to form magnesium chloride, which is another type of salt. Magnesium has valency +2 and chlorine as usual, you know that, -1. So there is 2 chlorine atom, they will receive 2 electron, and magnesium already, a single magnesium atom already has a power to donate 2 electron because of its valency +2. So how in the form? They generally create MgCl2. How this possible? Magnesium has valency +2. Right here. Chlorine has valency 1. How many magnesium will I need it? Cross it. 1 magnesium. How many chlorine will I need it? 2. Cl2. Magnesium chloride. This is the basic way of making chemical reactions or to form molecules. Okay. After this class we are done. You need to practice such kind of molecules as I will send you through WhatsApp. Okay. Till then, gracias.